Hi everyone, in today's lesson we're going to talk more about differential equations. So for today's topic, our goal is going to be, given the differential equation, dy dx, as well as an initial condition, I want to write a specific function y equals. So what our goal is going to be to do today is going to be to get rid of that c and actually put a numerical value in for it. So let's look at an example. All right, so example number 1. The given information is dy dx is equal to negative 2x plus 3, and the initial condition is that y of 2 is equal to 0. So just like we did yesterday, we're going to first find the function y equals. So let's take the antiderivative or integrate both sides. So when we integrate the left side, the integral of dy dx is just y. So we have y equals, and then when we take the antiderivative of the right side, remember add 1 to the power and divide by that power. So this should be negative 2x squared over 2 plus 3x and then plus c. So if we simplify it, we should get y equals negative x squared plus 3x plus c. So that is the generic form or general form. Now, that's what we did yesterday. My goal for today is now going to say, how can I use this information to find a value for c and then make a specific function? So if they give us that we have y of 2 is equal to 0, what that really means is that the x value is 2 and the y value is 0, right? If I were to write it similarly as f of x, the number on the inside is the x, and then the y value is 0, which it comes out to. So we're going to use these two conditions and put it into this equation to solve for c. So instead of y, I'm going to put 0, and instead of x, I'm going to put 2. So y is 0 and x is 2, and we're going to solve. So 0 equals negative 4 plus 6 plus c. 0 equals negative 4 plus 6 is 2, so 2 plus c minus 2 on both sides, and you get c is equal to negative 2. So our final answer, our specific function, is y equals negative x squared plus 3x plus c, which is negative 2. So y equals negative x squared plus 3x minus 2. This is my specific condition, my specific function that has a c value already written in for it. Okay, that's it for that example. Let's try another one. All right, I think after I did that first one, I think you guys can try this one on your own. So take a minute and write this down. So dy dx is equal to 4x plus 1 with an initial condition of y of negative 1 equals 2. So pause the video, try it on your own, and then hit resume when you're ready for the explanation. Okay, so we're going to integrate both sides. And the left side, again, is y equals. The right side, when you add 1 to the power and divide by that power, this is the equation that you should get in c form. And I'm just going to simplify it a bit. 2x squared plus x plus c. So again, this is my general form. And now I need to find the specific form using this information. So this number inside the parentheses is the x. This is what it's equal to, is your y. So x is equal to negative 1 and y is equal to 2. So in this formula now, we're headed over here. We're going to plug in our y is 2 and our x is negative 1. So y is 2, x is negative 1. And then find c. So we get 2 equals 2 minus 1 plus c. 2 minus 1 is 1, plus c, and then minus 1 on both sides. And you should have gotten 1 is equal to c. So now we're going to take this general equation and make it specific. So y equals 2x squared plus x, and now plus that c value, which is 1. And that's the answer that you should have gotten. All right, let's try a couple more. Okay, so number 3. Given dy dx is equal to 2 over x to the 5th, negative 2 over x to the 5th, with an initial condition of y of 3 is equal to 1 over 162. So if you feel like you want to try this on your own, remember, you could always pause the video, try it, and then hit resume, but I'm going to go through all of the explanations. So to solve this one, we integrate both sides, right? And again, adding a dx. But before we can do this problem, it would probably be beneficial if we took this 5 exponent and brought it upstairs. So I'm just going to rewrite it. So first I'll take the integration of the left side, which is y, and I want to integrate negative 2x to the now negative 5 dx. I'm basically taking this power, bringing it up, and making it negative. So now when I integrate the right side, I add 1 to the power. So when I add 1, I get negative 4. Divide by that number and add c. So y equals, I can divide this negative 2 and negative 4. That makes 1/2. So 1/2 x to the negative 4, and then plus c. So again, this is my general equation. And I want to use the initial condition up here, where the 3 is my x value, and the 1 over 62 is my y, so that I can find c. Okay, so let's plug those numbers in. So the y is 1 over 162. The x is 3. And we want to find c. So now would be a good idea to grab your calculator if you don't already have it out. I'm going to ask that you just type this part in and see what you get as a fraction. And then hit resume when you're ready for the answer. So you should get the left side is 1 over 162. The right side is actually the same thing, 1 over 162, and then plus c. And when you subtract 1 over 162 on both sides, you should get that c is equal to 0. So our final answer here is y equals 1/2 x to the negative 4, and then plus nothing. So that is my original equation that would have this as my derivative. Okay, last question for today. So problem number 4. So we have dy dx is equal to 1 over 2x minus 3 squared when y of negative 2 is equal to 6 over 5. So again, if you'd like to try this, feel free, try it on your own, pause the video, and then hit resume for the answer. So I'm going to integrate both sides. The left side is y. And when I integrate the right side, you should be thinking u substitution. So I'm going to let what's inside the parentheses equal u. And I'm going to take the derivative of both sides. So the derivative of u is just du. The derivative of the right side is 2 dx. And then divide both sides by 2, and I should just get that dx is du over 2. So let's go ahead and plug it back into our equation. So I have the integral of 1 over u squared, and dx is now du over 2. So if I write this out nice and neat, I have y equals the integral. I'm going to bring this upstairs. U to the negative 2 times technically a 1/2 times a du. And I think you can kind of see that. Now I can pull this outside, right? So I have y equals 1/2 times the integral of u to the negative 2 du. So again, taking the integration of this side, add 1 to the power, and divide by that power. and then plus c. And don't forget that you have this 1/2 in front that needs to be multiplied. So my final answer for y is technically a negative 1/2 u to the negative 1 plus c. And then we just have to put what we let u be. So I'm going to put u back in. So y equals negative 1/2 2x minus 3 to the negative 1 plus c. So this is my general equation, right? Now I need to find the specific one. So I'm going to have to use this initial condition to find it. So just give me a second. I'm going to write it on a separate page, and then we're going to move forward. Okay, so this is what we have. And my x value is my negative 2, and my y value is 6/5. So I'm going to go ahead and put in 6/5 for y. And I'm going to put in for x negative 2. And again, this is where the calculator would be helpful. So take a minute, type this into the calculator just the way you see it with all of the parentheses and everything, and then hit resume when you want the answer. Okay, so you should have gotten 1/2 plus c equals 6/5. And then we want to subtract 1/2 on both sides. So take a minute, type that in, and hit resume when you're ready for the answer. All right, you should have gotten 7/10. So that leaves me with my final answer of y equals negative 1/2 2x plus 3 to the negative 1 power plus 7/10. Okay, that's it for today. Try the problem set, and if you have any questions, let me know. Have a good one.